Hello, my name is Anna Fausta, and today our topic is what are wireless sensor networks and what are their applications. So let's start immediately. First of all, a small overview of what I will be talking about in this video. We would like to know what are wireless sensor networks, what are their main properties and components. We would like to see some sample applications around the world, and we would like to explore the types of sensor networks or some synonyms which are used next to wireless sensor networks. So first of all, what is a wireless sensor network? It is a network of individual and independent nodes, which we typically call sensor nodes, as for example here the small circles on this picture, and they're connected to each other via wireless links. These wireless links are typically not really planned or deployed, but they are rather spontaneous and rather random. There is also a special node typically in any of the sensor networks which I know or which are deployed around the world, which is called the sink or the base station. The difference is that the sensor nodes are typically connected to each other and eventually to the sink or to the base station, but they're typically not connected to the internet. They are a self-sustained network which is connected to the internet or to the outside world only via this sink or base station. This base station is typically also a little bit more powerful than a normal sensor node, but it can be also a very normal sensor node which is connected, for example, via cable to your laptop or to a desktop PC. So what are the main properties of wireless sensor networks? First of all, they are very resource limited. We typically assume that sensor nodes are small, tiny, they are cheap, they run on battery power, and their resources are very, very limited, which means that they have little memory, they have little programming memory, they have a small battery on board, they have a tiny antenna on board, everything which they have is small and tiny. You can imagine also a typical sensor node to be a computer from the 80s, beginning of the 90s. Right now they are of course in a smaller size, which is one of the main advantages, because we would like them to be small, to be able to deploy them everywhere, but at the same time we have to work with their limited resources. The wireless links, exactly as I already mentioned, are rather spontaneous and not really planned. Whatever, even if you are trying to plan them and trying to put two sensor nodes in a way that they perfectly communicate to each other, the experience shows that the environment where we put them, starting from agricultural activities to volcano monitoring to smart home, etc., they're so complex, these environments, that you actually cannot plan the deployment of the sensor nodes. So anytime you will put them and you believe you have planned it well, you will get some surprise that they're doing whatever they actually want. The main goal of a sensor network is actually to sense some phenomenon and to send this data to the outside world, typically through the sink or the base station. So a typical sensor network might be sensing temperature or humidity or acceleration or light, intruder detection, and so on and so forth. They will be maybe cooperatively pre-processing these events before they send them to the base station. This is rather rare, but it still happens. And they will be forwarding this data from one to another node before they reach the base station. And the base station will forward or store this data in an outside database, server, whatever. And it's really important to understand that the main functionalities of a sensor node is really to sense something and to send it somewhere. If you put one of these activities away, the sensor network doesn't make any sense anymore. But on the other side, something is missing here, which is typically missing. It's the actuation. This is a kind of a subtopic of wireless sensor networks, which are called then wireless sensor and actuator networks. Sometimes it's also called the IoT or Internet of Things. This is something slightly different, which we'll be discussing in a short while. But for us, it's important that a traditional wireless sensor network is actually sensing and sending, and that's all. Let us now look into some sample applications. These are just 3 which I picked, which are very representative. You can see them already deployed all over the world, and they will be doing their job really well. And many researchers are also orientating their work, their research, their further development to those applications because they're so well known already. The first one is vineyard monitoring. The typical application here is in the middle of the vineyard. Not only at one place but at several places you will find a sensor node like this one, which has its own battery supply, in this case the solar panel, and it would have typically temperature, humidity, sometimes leaf wetness sensor. This is a little bit more special. Sometimes they will have also rain sensors. Some of them have also chemical sensors on board, and so on and so forth. Whatever pretty much the users of this sensor network consider useful for their work, in this case, growing healthy and abundant wine, which is a good thing. Another very typical application is bridge monitoring, or in general actually structural monitoring. It can be buildings, it can be bridges, it can be tunnels, everything. In this case it is a very famous bridge in Greece which had some problems actually in the beginning, just straight after it was finished. And whenever they discovered, the engineers discovered that there is a problem, they actually installed a sensor network here which senses now the acceleration of this bridge at different points. And this is of course very useful for such a structure because the structure is mostly floating actually between these pillars, and they can get into very bad vibrations which may destroy the bridge altogether. The sensor network will see or will discover these events, that something that vibrations are going beyond what is normal, and they will give an alarm to the engineers on time. Very typical application. And the third application which I would like to present you is about animals. In this case I have cows here from Australia, but actually this application is very popular for all kinds of wildlife. You can see them on elephants, you can see these collars which the cows are carrying around here, on wildcats, on wolves, and so on and so forth. The idea is that these collars are gathering GPS information, so motion information. They're gathering also accelerometer data. They're gathering typical also temperature and other phenomena, and sending this data to the interested user, typically a farmer or natural reserve organizers and things like that. So it's a very typical application. However, it has one small clue here, that it is actually not statically deployed sensor nodes, but they are mobile. And so they will need to opportunistically send the data which they gather while they're, for example, going to a watering stand or passing by some other base station which can gather then the data. The other possibility is that the base station comes to them. For example, in a natural park reserve, the rangers will come with cars and to gather the information. Apart from these applications, there are tons of others which you can see also on the internet. These three are very representative, that's why I decided for them, but they're absolutely not the only ones which you can cater for with wireless sensor networks. So as a last thing today, I would like to present you also some flavors of wireless sensor networks, and to make the difference between what is a sensor network, for example, but what is also IoT, or the Internet of Things, what is a cyber physical system, what is a body sensor network, or what is low power wireless, which is also a very well-known kind of a buzzword. So let's start one by one. Wireless sensor networks, we already have seen them. The Internet of Things is something which is gaining a lot of momentum right now, and it's actually extremely similar to wireless sensor networks. It can be also called the new wireless sensor networking domain because it's a little bit more than sensor networks, but it also goes in a slightly different direction. So let us see what are the real differences between those two domains. In the Internet of Things, typically I mean really 99% of the time, each device is connected directly to the internet. So you can address this device from wherever you are. It has typically an IP address, and you can manage this device over the internet individually. This is not the case in sensor networks, where actually only the things are connected to the internet. There are advantages and disadvantages to both versions. If each of the devices is connected to the internet, the installation overhead is huge. Just imagine installing thousands of those somewhere, giving them IP addresses, connecting them to the internet, securing the connection, and so on. On the other side, you can then manage them individually and you have access to them from any corner of the world. In sensor networks, you have the advantage that you can just spread them and they work in the environment which you would like to have them. You only have to take care that the sink or the base station is connected somehow to the internet and you get all of your information out. So advantages and disadvantages for both, and it depends really on the application scenario which one you would like to have. The Internet of Things also uses typically standardized communication protocols and security because they're connected to the internet. So there you don't have that much freedom of movement, if you want, for researchers, for example, or for optimizing your network connections or your protocols, because simply you have to apply to some security standards. In wireless sensor networks, this is different because here we usually have hand-tailored communication protocols which fit perfectly the application and the environment, or trying to fit perfectly. And this is the main goal here. You have less focus on security because typically your deployments are somewhere in the wild where security is not really an issue, at least not the security which we understand in the internet. The device resources in Internet of Things are also limited, but not to that extent. Typically, the memory available, the processing power available is a little bit higher than for sensor networks. The power supply is also typically available. Internet communication protocols, they require a lot of power. They cannot sleep, which means that also they need actually a proper power supply. Otherwise, they'll be working only for a few hours. So this is not the same in sensor networks, where we actually have battery-powered sensor nodes and they can survive for a very long time because the communication protocols are well tailored. And something very interesting is that in the Internet of Things, because of all of these things also before which we have discussed, it is actually a purely unicast communication. So the sensor talks to a cloud, the sensor talks to a server, and vice versa, and that's it. In wireless sensor networks, this is different. We have the so-called converged-cast communication, where all of the data converges onto the base station. So it can be even multiple hop until it reaches the base station, but you actually gather it on the way and it converges all at one place. It is a completely different networking scenario than for the Internet of Things. What are body sensor networks? Body sensor networks are sensor networks which you wear on your body. It can be some smart wrist, it can be some sensors on your shoes for sport people, it can be anything you would like. The difference is really the environment itself. Now we're not talking about deploying the sensor network somewhere outside in an agricultural scenario, in a structural monitoring scenario, but we are instead talking about installing it on your body. This poses some challenges to the communication because you cannot use very powerful transmission, for example, because otherwise you will start cooking yourself. And you have to consider that you're moving around and so on. On the other side, some things become easier because you typically have also your smartphone with you, and all of these devices can connect to your smartphone instead of using funky new hand-tailored communication protocols. So it depends really on how you see it, but they have special BSNs or body sensor networks. They have special dedicated research areas with communication protocols, with application scenarios, and so on and so forth. A different flavor of body sensor networks is wearable computing, which is simply the idea that you wear the device, which is actually mostly the same as body sensor networks. These would be smartwatches, smart glasses, sport watches, etc. The difference is that the wearable computing typically focuses on one device. So here, for example, in this picture, we have just a smart glass, and we're not really interested in combining that with a kind of a health application. It is just one device which has some advantages, disadvantages, some features which we would like to have. Another related term which has now actually little to do with body sensor networks, but typically is combined with them, is the so-called e-health or digital health. where the idea is that you try to put all of your health data together. And for example, here, this plan of the German Ministry of Health to put all of your data, all of your health data on one chip, so that any emergency, any doctor can actually see your complete data and not only parts of it, and they're not depending on rather random information which comes out of the patient himself. And it's important to understand that e-health and digital health is much more general than BSN, but BSNs are typically part of the e-health scenario. What are cyber-physical systems? Cyber-physical system is very similar to IoT and to wireless sensor networks, but somehow people have more focused in CPS into integrating the devices and the deployments into the environment itself. So here, for example, you see this picture of a car production where all of the sensors, the robots and so on, they're one integrated environment. They do communicate with each other, but it's a highly tailored, highly planned deployment where everything works perfectly with each other like one organism. And they have less focus actually on communication, because the communication is really very specific, like A talks to B and B talks to C, and this is all pre-tailored. But it has more focus on the integration of the system and how to make them look and feel and act like one system. Examples beside the car production is, for example, smart grid or autopilot systems, robotics in general, and so on. So as the last one, what is a low power wireless? Low power wireless has emerged over the time whenever actually wireless sensor networks started separating from the Internet of Things. You remember that wireless sensor networks have their main goal or their main focus on energy efficiency and resource optimization, resource limitation, while the IoT has been following a slightly different path of going into energy is there, it might be not abundant, but I have my power supply and I can do a little bit more. So in communication protocols, that has a very big influence, because the communication protocols have either to go for one or another. They cannot really serve both worlds. So low power wireless emerged at exactly this time to make it clear that people working in this area, in this domain, are focusing on communication layers for energy efficiency. Typically for sensor networks, but not only, but it is simply focused on energy efficiency purely. This is the difference. So, in summary, what did we see today? We have seen that sensor networks consist of few to thousands of nodes, which is sometimes a problem. We have seen that the nodes are typically low cost and small size. We have seen that the sensor network design is really tightly coupled to the application it serves. So you typically have first your application at hand and then you design your sensor networks, and there is no solution which serves all of the applications. And the main challenges which arise in sensor networks is the sensing itself, to get proper, calibrated, high quality data out of this node, which has limited resources. Communication is a big problem, especially in challenged environments like outdoors, somewhere in Australia where the cows are living. It is not really easy. Energy efficiency is one big focus and big challenge for sensor networks. And last but not least, the installation or the deployment itself. This is something which is sometimes neglected in the literature or in the domain itself. But it is a huge problem to deploy thousands or tens of thousands of nodes in one, let's say, outdoor environment. It is simply a big task, and since all of the wireless links are rather spontaneous, it becomes just uncontrollable environment. So these are the 4 real big challenges which are still kind of open, and the topic is still waiting for new ideas to come. Thank you very much for your attention.